Hey everybody. Today we're talking about the addition rule for probabilities. There's two versions of it that we're going to talk about, a simple one and a slightly more complicated one. The more simpler version goes like this. If A and B are disjoint events, so ones that don't overlap, they have no outcomes in common, they're mutually exclusive, then the probability of A or B is just the sum of the individual probabilities of A and B. In slightly more mathematical notation, we sometimes write the probability of A union B rather than probability of A or B. Those are just synonyms in this sense. Here's an example. A fair die is rolled twice. Let A be the event the first roll is a 6, and let B be the event the sum of rolls is 3. Now these events are disjoint since the sum can't be 3 when the first roll is a 6. So we're going to use the addition rule to get the probability that A or B occurs, that we either have the first roll be a 6 or the sum of the rolls is 3. The probability that the first roll is a 6 is 1 in 6. There's 6 possible outcomes, one way that the event can occur. And the probability that the sum of the two rolls is 3 is 2 in 36. There's two ways to get a sum of 3, if you get a 1 and a 2, and if you get a 2 and a 1. And there are 36 possible outcomes when you roll two fair dice, 6 times 6. We add those two numbers up, we simplify the fraction, and we get 2/9. Here's another example. It's a good place to pause the video and do it on your own before moving on. The relative frequency of 4 basic blood types are shown below. So here I've ignored the RH factor, positive and negative. What's the probability that a randomly selected person has type B or type AB blood? So once again, these are disjoint events. They can't both occur. You have one type of blood only. And so we just add the individual probabilities. We add 10% and 4% to get 14%. When events are not disjoint, the addition rule gets slightly more complicated. It looks like this. The probability of A or B is the probability of A plus the probability of B, just like before, minus the probability of A and B. And sometimes instead of A and B, we write and say A intersect B. And that just means A and B. I think this picture is really helpful when we're talking about this version of the addition rule. When A and B aren't disjoint, outcomes in the intersection are included in both probability of A and the probability of B. And so when we just add those two probabilities, we kind of double count the outcomes that are in both events. And so the minus probability of A and B takes that into account and subtracts off the double counting one time. Another example, a standard deck of playing cards includes 52 cards split evenly between 4 suits, hearts, diamonds, clubs, and spades. And each suit has 13 denominations. A card is drawn at random, and I'd like to know what's the probability that the result is a diamond or an ace. And when I say or, I want to stress that I'm always meaning or both, and that's totally normal in statistics and probability theory. So pause the video again, and then advance when you're ready to see my solution. So we're going to use the addition rule, and the big tip-off there is the word or. So the probability of a diamond or an ace is the probability of a diamond, plus the probability of an ace, minus the probability that the card is both a diamond and an ace. So there's 13 diamonds out of 52 total, 4 aces out of 52 total, and 1 ace of diamonds out of 52 total. So we're doing 13 50-seconds plus 4 50-seconds minus 1 50-second. We get 4/13, about 30.8%. One more example. We have a survey asking 242 people about their smoking habits and their seatbelt use. Here are the results. We'd like to know the probability that a randomly selected student doesn't smoke or doesn't wear a seatbelt. So again, take a second, pause the video, work it out before moving on. So we're going to use the addition rule again. It's another or problem. We're going to find the probability that the person doesn't smoke. There we're looking at the bottom row of this table. We see that there are 169 individuals that smoke 0 cigarettes per day out of 242 total. We're going to find the probability that the person doesn't wear a seatbelt. And then we're looking at the total column on the far right. And we have 114 people that don't wear seatbelts out of 242 total. Then we're going to find the probability in the overlap, so the probability that somebody does not smoke and doesn't wear a seatbelt. So there I'm looking at the second row in the main part of the table there on the leftmost column, 81 out of 242 total. So now I'm just plugging into the addition rule. I'm taking P of A plus P of B minus P of A and B to get 202 out of 242, about 83.5%. Now there is one other way to do this problem, at least. We can do the probability of A or B just by adding all the individual probabilities in this table that are in that event. So you can imagine me circling the numbers 88, 81, 9, 18, and 6 because those are the ones in the column for 0 cigarettes per day and the row for doesn't wear their seatbelt. One of those or the other. Then I just add all those up and I get the same answer.